Hey, hello there. Let's talk about today's Leetcoding challenge question. It is called SAM tree. So given two binary trees, we want to write a function to check whether these two trees are the same. So the solution is pretty simple. You're just going to pick the tree traversal strategy of your favorite and then apply that tree traversal strategy on the two trees simultaneously. Have the tree traverse step in sync between these two trees. If you sync them up, then any iteration you look at the two nodes you currently add to both trees, they have to have the same value if the two trees are the same. If at any given point, either during this process or after the process, if there are any kind of difference, that's suggesting those two trees are not the same. So yeah, in short, pick the tree traversal strategy and then apply that on both of those trees in sync. Any contradiction during the time or afterwards is going to be suggesting they are not the same. If we don't encounter any of that, then they have to be the same. So that's pretty much it. So let's code this thing up. So we have two containers to hold the nodes that we are yet to visit during our traverse. I'm using a deck so that it can be a little bit flexible. In the beginning, for both containers, the only stuff on there is the root node for the tree. The looping condition is that while we still have some nodes, we can keep traverse from both trees. Then we advance them in the same fashion. So we pop the node out of this container. So if I'm using pop from left, I'm doing BFS search. If I'm doing pop from the right hand side, it's the DFS search. So I can be pretty flexible here. So once we look at the next node during our traverse, there are a couple of situations. The first situation is that these two are both null pointers. That means they are the same, so we can continue. And because they are null pointers, they don't have children, so we don't have to push anything onto the queue. The other situation is one of the node is null pointer, the other node is actual tree node. Then that's saying these two trees are not the same. The last situation is we do have two tree nodes. Then we have to compare the value. If they are not the same, that's also a violation, so we can return false. In the fourth, the remaining situation is that both are valid tree nodes and they have the same value. Then we can put the children onto the queue. So there are four branch here. So the first one is that none of the two nodes we're looking at are actual nodes, so both of those are null pointers. Then we can continue. So this test is saying that only one of the node is a null pointer. One of the node is a null pointer. Because we handle both of those are null here. So the only thing that can trigger this second criteria is that one of the nodes is a null pointer. That's indicative of a difference, so we can return false. Otherwise, we do the comparison of the nodes values. The remainder case is the good case, where two nodes are valid tree nodes and they have the same value. So the only thing we do is to extend the queue. So in the end, if one of the one of the queue become empty, exhausted the traverse in one tree, that would trigger this while loop to break. So in the end, all we need to do is to test do we have some residual remaining nodes on the other queue? If that's the case, then it's saying that they are not the same. Otherwise, they should be the same. So there you have it. This is the BFS search solution to this problem. The time complexity and space complexity for this is your typical tree traversal. In the worst case, it's both order of n in terms of time and space. In terms of time, because you have to look at every node exactly once. For space, in the worst case, you have to store the, either in the extremely unbalanced case, it's a single linked list. You have to store everything. If you're doing DFS, actually. If you do BFS, the worst case is that it's a full tree, complete tree. Then you have to store n over 2 number of nodes on the last level there. So, in short, for both time and space, it's order of n. So that's the iterative BFS search. If you change the pop left to pop from right, just simply pop, you convert this into DFS search solution. Yeah, that's pretty much it. Some of the people ask me why I'm preferring doing iterative approaches over recursive. The reason being that when I think the complexity of iterative approach is low enough that I can handle, I always prefer iterative approach, because just looking at the code, I can visualize it much better. But that doesn't say I couldn't solve it with recursively. So let's actually give it a try today. So I'm just going to call this iterative. So the recursive solution is pretty much gonna only be the DFS solution, because recursive solution is by nature DFS. You're gonna call the function and call the function. You couldn't really apply the BFS search easily, I think, unless there are some kind of hack. Otherwise, it's gonna be the DFS code. The logic is gonna be for the two nodes you're looking at, they have to be the same. And if they are the same, you call this recursively on both left and right, and they have to be both correct as well. So it's pretty much essentially this logic, but without using a loop. Substitute the loop by the recursive calls. So how do we solve it? If just convert the logics onto up the parent level. So that's this logic. If both of those nodes are, if both nodes are null pointers, then they are the same. Otherwise, we test if only one of the node is a valid node, then it's definitely false. The third situation is if they don't have the same value, then it's also a false. So it's pretty much just copying the body of the while loop and put that onto the upper level here. So after this three basic cases be excluded, all we need to do is to call this function recursively on left children, the two left children and two right children, and they have to be the same. So that's the recursive solution to this problem. Let's give it a try. Seems okay. So it's accepted as well. Yeah, as I said, When the complexity is not too much, I always prefer iterative approach because that's just I can imagine how this works in my brain much better compared to the recursive solution. For recursive one, um, it's not so natural to me at least. Yeah, so that's the question today.